Hey there, everyone. This is Caitlin. I'm here today to help you out with identifying and otherwise analyzing your spinach pigments. So here's an example of what your TLC plate may have looked like. This is the example where three different lanes were spot. This was the 7-3 plate. And don't worry if you don't have three lanes on all of yours. The student who made this, or I think actually it was a TA who did this just for fun, didn't need to do the 1 and the 7 because they had already figured out that 4 spots were best. So we're only looking at one lane at a time is what I'm trying to say. So don't worry about the other guys. But all of these do have the same pigments inside. They have 1, 2, 3, 4, 5, 6 distinct spots that you can see here. And before I move on with analysis of this particular plate, I want to click back so you can remind yourself of what those pigments or the structures actually are. In lecture, you were given, and also in the experiment 3 PDF, you were given the structures of all of the pigments that you may see on your TLC plate. Now, some of them may have separated, some may not. And again, I started with the plate that has the most spots. So let's just remind ourselves of some things. Here we have the chlorophylls. These are going to be the very, very bright green ones. So let's see if we can find those. Ooh, all right, here we go. So what I had identified as 3 and 4, but I think I'm just going to get rid of those numbers just for simplicity. These two are going to be identified as the chlorophylls because they're green, and this is bothering me. I have to change the color. Magic, that's better. So those are the two chlorophylls. Now we're going to be looking to see if we can tell the two apart. There was chlorophyll A and B. Now check it out. Chlorophyll A has just a methyl group in that X position, whereas chlorophyll B has an aldehyde. And we would expect that because it has a carbonyl or an oxygen in it at all, you would expect chlorophyll B with the aldehyde to have a greater polarity because of the aldehyde. So now we can assign that based on the fact that the silica plate, let's go back to that. The silica plate is composed of it's composed of silica, but it's very, very polar. So that's something that we're going to keep in mind, is that silica is super duper polar. So anything that is on the plate that is more polar will stick towards the origin and move less. And anything that is less polar is going to move away from the origin and move more. And so we talked before about how chlorophyll B has an aldehyde, so it's going to be more polar. So we can probably assume that that's chlorophyll B, and the one up there is chlorophyll A. Now the same could go for the phaophytins. Let's go back to those. In that phaophytin B is going to be a bit more polar. This time we're looking for some green-gray. I tried to make it that color as best as I could. So we're going to look for the green-gray spots, and we'll identify if they separate, first of all, and then which one is which, A or B. So in this particular plate, we do have a green-gray spot that's going to correspond to the phaophytins. However, it looks like they didn't separate, so we just assign them as the phaophytins, okay? Whereas the chlorophylls actually did separate into different spots. Now in your plate, you might separate the phaophytins, and if you have 2 green-gray spots, then hooray! And you can assign the top one A and the bottom one B. Let's go back to our list of molecules to see who's left. And here's who we have left. The carotenes, namely beta carotene is going to be bright orange. And then the xanthophylls, the ones there on the bottom, these are going to be yellow. Can you even see that? Yeah, sure. So let's go back and look for the carotenes first. And boom. Nice bright green, bright orange spot that goes with beta carotene. Again, if you just said the carotenes, that's fine. It's like a family of compounds that have different things happening in the carbon chain. But yeah, so beta carotenes are way up there, right there at the solvent front. A very high retention factor. The retention factor may have been even 1, which means that it moves entirely with the solvent front. We'll get back to that. But yeah, we've identified the carotenes. The only thing that's left, I'll keep this in orange, are these 2 spots that are going to correspond to the xanthophylls. There's really no way of knowing whether those 2 spots are, lutein and violxanthin or whatever. There's 3 xanthophylls that you're presented in 2 spots, so you just call them xanthophylls. But you are going to be getting the retention factor for each individual spot. So let's go back so you can remind yourself what the xanthophylls were. And here they are. These are the 3 xanthophylls: lutein, violxanthin, and neoxanthin, and you're not expected to assign those 3 to the 2 spots. Now, there was probably only 1 plate that gave this many spots, and you might not have seen this many spots, or you may have seen more spots. It's really on you and the spinach of the day. But there are 3 other plates to analyze. We have the 9-to-1 plate. We have a 7-to-3 plate. Remember, this is 9 for the hexanes and 1 part ethyl acetate. So here's another repeat of the 7-to-3 plate. Here's the ethyl acetate solvent, and here's hexanes. And remember, these are the solvents, otherwise known as the mobile phase for TLC. Okay, we're going for not too nonpolar, as in the case of hexanes. In this case, we see that there is very little movement. Pretty much only the carotenes have moved here, and then over here down at the bottom, this is just everything else. This is just a big old mixture of pigments that all have a retention factor of 0. So if you're putting together your table, that's what you would report for that one big blob. Up here next, an ethyl acetate. This is way too polar. What's happening here is all of the pigments got moved up all together in a big old smear, and there's just really no way to differentiate on this plate, at least, probably not on yours either. I'm going to skip over the 7-to-3 plate and then move to the left to see the 9-to-1 plate. This is the first one where you have the 3 lanes, and we can just look at any one of them. I'm going to look over here and say that we have this 1 spot. This is like a big old mixture. Once again, an RF value, retention factor of 0. We have, a nice little extra pigment that stood out, and we can remind ourselves what the green-gray pigments were, the phaeophytins. Okay, so you did have separation of the phaeophytins, and someone drew over this so you can't see it that well. We have the carotenes there as well. So your results might be a little bit different from this, but this is the kind of thing that we're looking for. What happens if we add a very non-polar solvent? Well, it looks like only the really non-polar stuff, not cartones, carotenes. Let me fix that. But yeah, a non-polar solvent will just pull up the non-polar components. The overly polar solvent pulled up everything all together, because the carotenes would be moving because they're the least polar, but the phaeophytins and the xanthophylls and all those are moving as well with this very, very polar solvent. We see here between the 9-to-1 and the 7-to-3 that these are like medium polarity or medium polar mobile phase, and for mobile phase. And that works out for us, right? We definitely have better separation on both plates than on one solvent alone. So mixing them is a good thing. And in this particular example, we find that 7-to-3 is the best because it gives the 1, 2, 3, 4, 5, 6 different spots, whereas in the 9-to-1 mixture, we only see 3. But it really just depends on what you're going for. So in some pre-lab questions, you're asked, what about if you just wanted to pull out the carotenes? Or I ask a question similar to that. And if you just wanted to remove the carotenes, the 9-1 would be the way to go. 7-to-3, you have some space in between there, but it's definitely a better separation of the carotenes in the 9-to-1 plate, because there's a larger distance in between. So those are just spots. Let's go back one more time and look at the structures, and that'll be the end of it. If we remember back to the order, we have the carotenes that were the least polar, and we saw that they had the lowest retention factor. I was right the first time. Highest retention factor, meaning they are not retained. Their retention factor is pretty much one. They basically move with the solvent front. Then next we had the green gray. So this was right. This traveled the most. So I'll give it a number one. We had the green gray, the phaeophytins, followed by the green chlorophylls. And this is cool to see that removing that, or sorry, adding in that magnesium ion makes it more polar, so it moves less. The carotenes move less along the plate. They had lower retention factors than the phaeophytins and carotenes. And what we had below the chlorophylls were the xanthophylls. And should you see three spots? Sure, you can definitely rank and say that since violxanthin is the most polar, say I have here is the most polar, then that should have the very lowest retention factor. But otherwise, all the xanthophylls are assigned to get it. So I hope you found that helpful in really relating your data of those spots on a white plate to the actual molecules that are behind it. Thanks very much for watching and have a wonderful day.